Hi, this is the fifth lab, which is your choose your own lab, and I decided to do my lab on 2D projectile motion since we haven't covered it in class yet. So, what this problem consists of is a ball rolling down the y-axis until it hits the wind region, which is a hairdryer blowing the ball perpendicularly for a short period of time. The ball then rolls freely until on a skewed axis until it hits the blue box over here, and then what we're trying to do is given the final distance on the blue box relative to its origin, calculate the force acting upon it. And the results was that the ball traveled less in the x direction than expected, being that it only traveled 0.21 meters, whereas um, it expected to travel 0.23 meters in the x direction. So some of the essential formulas that we need to know for this lab include F net, or Newton's second law, which is mass times acceleration, Vf equals Vi plus acceleration times delta t, and Rf equals Vi times delta t plus 1/2 a delta t squared. So, so this is the video of the ball rolling, and then as you see, it hits right here. So now viewing up the entire experiment, we want to calculate how much force that the wind was acting on the entire ball. So in order to do that, we're going to need to look at the calculation part. And given that the mass of the ball was about 10 grams, the total time is 1.668 seconds, origin was at 0, 0, 0, this total displacement was 0.23 meters to the right and 0.94 meters along the y-axis, and the line of force was at 0.36114 meters, which is at 0.501 seconds, which is the starting line of the acceleration, and it ended at 0.46 meters at 0.71 seconds. So assuming the ball is on a frictionless surface and that the ball velocity is constant throughout the entire experiment, we can get the velocity of the ball by calculating this equation, which is velocity equals final location minus initial location over the change in time, and after plugging everything in, it happens to be about 0.562 meters per second, which we're going to plug into VPython later. So the next one is acceleration, which is equal to d equals v initial times time plus acceleration times change in time squared over 2. And displacement is going to be displacement along the x-axis along in the wind region, which happens to be about 0.02167 meters. V initial at the time was 0 meters per second, so this entire block over here is disregarded. Acceleration is what we're trying to solve for. 0.2 is 0.705 minus 0.501 squared, so hence 0.2. And 2 is a constant that was in the original equation, and that finally gives us 1.0835 meters per second squared. Therefore, from that, we can calculate that the force acting on this entire ball was about 0.010835 newtons, which is from force equals mass times acceleration. Now we're going to look at the VPython code, which is split into 3 parts. Pre-wind time, which is from 0 to 0.501 seconds. Wind tunnel, which is from 0.501 to 0.71 seconds, and post-wind, which is 0.701 to 1.668 seconds. So noting all of our initial data, we plugged all that in here. Ball mass, which is 0.01 kilograms. Initial velocity, which is calculated from before. And then we separate into, as I said before, we separate into 3 parts. The first and the last part don't have acceleration since it's acting on its own. And then the second part, which is the wind tunnel, which is pushing the ball along the x direction. So once we do that, we get this representation, and then it tells us that the ball is supposed to land 0.23 meters along the x-axis and 0.93 from the origin. And comparing that to our observed data, we see that the blue line traveled less along the x-axis than expected, and there's also a slight deviation in the curve in the acceleration time period as well during the wind tunnel. So we're gonna ask ourselves, why did the ball deviate so much from the expected path? Well, first of all, there's also frictional force, which could explain why it did not travel as far in the x direction as expected. And plus, second of all, there's also uneven distribution of the air force. Looking at the diagram on the right, the ball first comes in contact with the air force, and then it pushes the ball through the top, which kind of pushes the ball towards the bottom right. So that kind of slows the ball down, but at the same time, it's pushing the ball to the right. Uh, Then the ball is parallel with the air force, so that's when the ball is actually traveling to right. And then finally, the ball is being pushed from the bottom right corner, which pushes it up right. So this uneven distribution of force kind of skews the ball's path a little bit, and these are all the possible reasons why the ball did not go through the expected path.